Let's unlock a hidden secret inside countless machines, the cam and follower system. It's a simple, elegant mechanism that transforms basic rotation into complex, precise motion. Think of it as the mechanical brain behind engines, packaging machines, and even toys. The cam and follower choreograph the movement of parts, ensuring everything happens at the right moment. All it takes is a specially shaped cam and a follower pressed against it. As the cam spins, its shape pushes the follower in a specific, repeatable way, creating rises, falls, or pauses. This system is pure mechanical genius. No electronics, just clever design. Once you spot it, you'll see its influence everywhere. Let's break down how this duo works and why it's so powerful. Ready to dive in? First, what exactly are cams and followers? A cam is a rotating or sliding piece with a specially shaped edge. Think of a lumpy wheel. Its profile is the blueprint for the motion you want. As the cam turns, its shape pushes the follower, which rides along the cam's edge. The follower's job: to trace the cam's profile and turn it into useful movement, like opening a valve or moving a lever. The follower is usually held against the cam by a spring or gravity, ensuring constant contact. As the cam rotates, the follower rises, dwells or falls, following the cam's every contour. This simple interaction is the heart of the system. The cam thinks, the follower acts. Together, they create endless possibilities for motion. That's the magic of cams and followers. Now, let's meet the different types. Followers come in several shapes: knife edge for precision, but wears quickly; roller for low friction and high speed; flat-faced for handling force; and spherical-faced for misalignment. Each has its strengths. Engineers pick the best fit for the job. Cams also vary. The most common is the disc cam. Think of the lumpy egg shape that moves the follower up and down. Disc cams are everywhere, especially in car engines. Cylindrical or barrel cams have grooves cut into a cylinder. The follower rides in the groove, creating smooth back and forth motion. These are great for textile machines and automated equipment. Face cams have grooves on the flat face of a disc, offering compact, precise movement. The choice of cam and follower shapes the motion. Accuracy, speed, and durability all depend on the design. That's the beauty of mechanical engineering. Simple parts, endless combinations. Pick the right pair, and you can choreograph any movement you need. That's the power of cams and followers. Where do we see cams and followers in action? The classic example is your car's engine. Cams open and close valves with perfect timing, making the engine run. In factories, cams fold boxes, fill containers, and seal packages at lightning speed. Textile machines use cams to weave fabric, moving needles and shuttles in complex patterns. Even in robotics, cams handle repetitive pick-and-place tasks with unmatched reliability. Why use complex electronics when a simple cam can do the job for millions of cycles? Mechanical toys and automatons use cams to create lifelike gestures: a nod, a wave, a blink. From engines to toys, cams and followers bring machines to life. Their reliability and precision make them the backbone of countless industries. That's real-world mechanical magic. So, why are cam and follower systems so important? They turn simple rotation into custom, controlled motion. No computers needed. The motion is built into the cam's shape, making it reliable and low maintenance. In high-speed factories or engines, you want systems that just work. Cams deliver that. Multiple cams on one shaft can synchronize complex movements, like a car's camshaft timing dozens of valves. It's an elegant, robust solution. No electronics to fail, just pure mechanical design. Cams and followers are a cornerstone of engineering, versatile, cost-effective, and precise. They empower engineers to create intricate motion with confidence. Next time you see a machine in action, Remember the hidden dance of the cam and follower. That's the marvel of mechanical design.